Okay guys, so this is gonna be a review on how to build our circuit for lab number 3. This is a circuit that we're supposed to build, right? And I went ahead and I connected our analog discovery to on our breadboard. So pretty much what you can see here is the positive um, end of our power supplies on the ground over here. So starting from this point, we're gonna build our circuit. So our power supplies is represented by this little circle here. We have the plus minus here. I'm gonna start building from this point. Okay. So I already got all the resistors that I need, and the first one that we're gonna use is the 100 ohm resistor, which is this one, that is connected with our positive end of our power supplies, as you can see here in the diagram. So let's say that we connect this 100 resistor next to our positive here, right? This is gonna be our reference. This is not our reference to start building. So I'm connecting one end of this resistor with the positive side of the power supply, and I'm connecting the other end of this resistor somewhere else. It doesn't matter where do you put it, but let's say I'm gonna put it here, right? And then we need to connect from our diagram. We need to connect the 470 ohm resistor with that resistor that we just connected in the same point in this same point, right? So this node is all this row right here, if you can see. Okay, so let's say that we connect this one here, right? And we connect the other end on the other side of the breadboard like this. Okay, so I'm doing this because I'm able to do this because this line from F to J is not connected with this line from A to E. If you can see here, there's something in the middle, like a hole in the middle that disconnects these two lines. So I'm saying this because you might say, okay, you're connecting this end of this resistor in the same node as this one, but they are not actually connected together because you have this in the middle. Okay, so I'm able to do this, and the same happens for each breadboard that you use. For example, this one here, I have a big one. You have lines separated with this columns. Okay, so that means that this line is not connected with this line. Okay, let's continue. So following the diagram, we have also another resistor connected at the same node, and that goes up here, the 68 ohm resistor. So let's do that. Since it is connected at the same node, we can plug it here in the same row, right? And let's say that we connect it here. Okay, so the important thing here is that all these three resistors are sharing this node, okay, which is this node right here. So this is gonna be our B1, okay. And let's say that then we want to connect this 2.2K ohm resistor, which is this one. This one is sharing the other end of the 470 ohm resistor, which is this one, right? So they are connected at the same node. So all this row represents B2. So we're gonna connect this here next to it, and going down like this. Okay, it doesn't matter where you connect this, the other end of this. It can be either here or in the road above it, or whenever you want, whatever you want. Okay, and then we have our, in that same node B2, over here we have our 1.5 kilo ohm resistor. So I'm working right now in this node right here. So we plot this in the same node of these two, this one and this one, 2.2 and 470, right? And if you notice, then the other end of this resistor must be connected together with the 68 ohm resistor that we connected before. So it's gonna be a little bit tricky. If you see, I should connect this end of this resistor next to the 78 ohm resistor here. It's gonna be a little bit difficult, but let me try. Maybe I can, instead of connecting the 60 ohm resistor here, I can change it to here, right? And then this little resistor can go here next to it, next to this one. Okay, so from our diagram we see that 1.5 is sharing the same node with the first 70 ohm resistor, which is this one, and you can see that is actually sharing the same node. Is sharing with 470 and 2.2K at the same time, and on his other end is sharing the node with the 68 ohm resistor right here. So this is gonna be, this is B3 and this is gonna be B2. And then we are missing the 470 ohm resistor, which should be sharing B3, and then it's connected, and the other end is connected to the ground. So this is going to be something like this, right? And going down next to the 2.2K ohm resistor, because this end of this resistor is also connected to the ground. So we're gonna do that. Okay. And then we need to connect these two to the ground. So we're gonna use a wire to be able to make a bridge in between these two. In between these two. And the ground of our power supply. Okay, so this is the circuit. The main idea is to follow the diagram and to be clear that which one is going to be your B1, B2, and B3, like your nodes. Be aware of which resistors are sharing nodes with other resistors. So this is from our circuit. B1 is going to be this row right here. B2 is gonna be this row over here, and B3 is gonna be this row up here, and then our reference here. So what happens if we want to measure something from this circuit? So let's say that we want to measure B1 first. We need to power on our analog discovery 2 first, and then whatever measuring like that we want to do, we plug our reference first, right? And then we measure in any node that in the node that we want to see. So let me power on this first. And once I do that, I'm trying to make this work. Okay, supplies, 5 volts. We set up the power supply to 5. We turn it on, and then for example, if I want to measure B1, this node here, I put one of this, the black one. Sorry. See. So we connect the black one to the reference right here, and then the red one should be going to our B1 here. Let me show you. Our B1, where in our circuit is this row. You see? The same if you want B2. B2 is this row right here. So we don't change the position of this black wire, and we pretty much just measure here. See? And then if we want B3, we do the same thing. We keep the black wire over there, and we measure here where B3 is. And that's all the circuit. That's all what you need to do for your circuit.